All right, let's look at example 211. It says find the matrix for the reflection across the line y equals a half x and find the image of the triangle shown here. Okay, so first up, let's get the matrix. Really all we're doing here is we're taking 1/2 for m and plugging it into this up here. So to get the matrix, we get 1 over 1 plus a half squared. Half squared is a fourth. Then let's see, 1 minus a half squared is going to be 1 minus a fourth. This down here, that's a fourth minus 1, so that's negative 3/4. And the other two corner entries, 2m and 2m, that's 2 times a half, so those are both 1. All right. Let's see, this thing on front, this is 5 over 4. And when you take the reciprocal of it, you get 4 over 5. So we've got 4/5 times 3/4, 1, 1, negative 3/4. So if you distribute that through there, you get, let's see, a top number, let's see, the 3/4 times 4/5 will give you 3/5. And the ones give you 4/5. And I am going to rewrite this using decimals because those are nice decimal numbers. 3/5 is exactly 0.6. 4/5 is exactly 0.8. So that is my answer right there. Well, that's the answer to the first part, find the matrix. Then it says find the image of the triangle shown here. Now, I mentioned this before, but it's been a while. But when you have a linear transformation, to find the image of this triangle, all we have to do is find the image of each one of those vertices, and then just connect them with lines. So what we'll do, I'm going to start off doing them one at a time. So this point is 0, 0. And if you multiply this out times 0, 0, you just get 0, 0. So that point gets mapped to itself. I'm going to put the image here with big purple dots. Okay, the next point over there is right here. This is the point, let's see, 1, 0. So if I put that into here, when I multiply this out, I get, let's see, that's going to be 0.6, and then 0.8. So 0.6, 0.8. If I graph that on here, remember each one of these little minor grid lines is 1/2. So 0.6 is going to be, if I do that, I'm going to go over, let's see, 0.6 is going to be here-ish, and then 0.8 is going to be there-ish. So looks like that looks good for this point. And while I'm at it, I'm going to draw in a little line here. This maps to there. Okay, and then the last point, this is the point 1, 2. If I put that in here, 1, 2, let's see, what do I get here is 0.6 plus 1.6. Is that right? Yeah, it's basically 6 plus 16. And then down here I get, when I multiply that out, I get 0.8 minus 2 times 0.6. So 8 minus 12 is negative 4, so this is negative 0.4. All right, so 2.2 and then negative 0.4. So 2, let's see, that would be 2.5, so 2.2 is going to be here-ish, then down 0.4, so that's a little less than a half, so there. And so this point here maps down to there. And now we can just connect these guys with lines. So I get this, this, and this. So that purple drawing there is the image of the triangle that we started with. Now, if you want to do this using Octave, you can do all of this at once. Let's see, that's not right. Here we go. So, like in Octave, if I put this in, my matrix A is, let's see, it's a 3/5 or 0.6, 0.8, negative, or no, 0.8, and then negative 0.6. So I can put that in like this, and then I'm just going to call this matrix. What I'm going to do is I'm going to make a matrix with all of my original points in it. So 0, 1, 1, 0, 0, 2. Okay, what that B is, each column is one of the points that we had. So we got 0, 0, 1, 0, and 1, 2. And if you just multiply these together, it gives us the images of all 3 points. So you can do this, in just one step there, plot them out. Now I'll mention the orientation. If we look at it with this triangle, the original triangle had a right angle here. So if you start at the 0, with this one, if you go, let's say clockwise, you go from 0, right angle. Oh wait, I'm on the wrong one. If we go clockwise, we go 0 on the original to the not right angle to the right angle. On the image, if we go clockwise, we go 0, right angle, and then the not right angle. So the orientation changes there. Another thing you can do, this drawing is getting kind of messy, but this is supposed to reflect across this line. So these this point and its image are directly across the line from each other. Same with this. This point and its image are directly across the line from one another. All right, so I did that out in excruciating detail, and I want to do the example 212. I'll save it for the next video, and I think it's going to go a good bit quicker than this one.